In our lesson today, we're going to look at rates that involve complex fractions. And we're going to start by looking at an example where we have three different plates of fruit. It says, how many pears must you place on plate number 3 so that the ratios of apples to pears are equivalent for all 3 plates? But write the ratio of apples to pears for each plate and then explain your reasoning. Okay, so if we look at plate number 1, I can see that there are 4 apples and there are 2 pears, so the ratio would be 4 to 2. Apples to pears. On plate number 2, I can see that there are 6 apples and 3 pears, making the ratio 6 to 3 rather. And on plate 3, I see that there is 1 apple. I have to figure out how many pears would go on this plate so that all 3 of these ratios would be equivalent to each other. Okay, so quick glance, I noticed here that to get my number of pears, well, the pears is half the number of apples in each case. 2 is half of 4, 3 is half of 6. So if I've got 1 apple, I would need half that amount, which actually is 1/2. I would need half of a pear to go on that plate so that all of the ratios are equal to each other. Okay, I could also have made a table, apples to pears. And if I had 4 apples and 2 pears on plate number 3, if there's 1 apple, well, to go from 4 apples to 1, I would divide by 4. I would do the same thing to my number of pears. 2 divided by 4, well, again, that's going to get me to 1/2. So that proves again that I need to put half a pear on plate number 3. Okay, so I can say that the number of pears is always half the number of apples. Okay, the number of pears is always half the number of apples. Okay, so these were the ratios for the 2, 6 to 3, 1 to 1/2. And remember that ratios can be written also as fractions. So if I turn this into a fraction, that would be 4/2 for the 2. And if I turn this into a fraction, 6 to 3, 6/3. So then if I turn this one into a fraction, 1 to 1/2, that would be 1/1/2. Okay, and that looks a little funny. Notice what we've got here, okay? You have a fraction inside of a fraction. This is called a complex fraction, okay? A fraction inside of a fraction is called a complex fraction. Here we see that the denominator is a fraction. Now, for a complex fraction, the fraction could be in the numerator, or it could be in the denominator, or it can be in both parts, okay? The thing to remember is that if you have a fraction inside of a fraction, that's what we call a complex fraction. So we just stated that when we have a fraction inside of a fraction, that is what we call a complex fraction. A complex fraction is a fraction with a numerator, a denominator, or both that are also fractions. A complex fraction is in simplest form when both the numerator and denominator are integers. Okay, so what we want to do for each of these examples is simplify the complex fraction, again, making both the numerator and the denominator integers. Notice that in each example, we have fractions in the numerator and denominator. The way that we're going to do this simplifying is by remembering what a fraction represents, okay? A fraction, don't forget, represents a division problem. So this 3/8 over 5/16 is really the division problem 3/8 divided by 5/16. And if I wanted to evaluate this, I would actually, instead of dividing by 5/16, I would multiply by the reciprocal of 5/16. So I would end up doing 3/8 times 16/5. Well, before I multiply, I know that I can simplify with 8 and 16. 8 goes into itself once, and it goes into 16 twice. No other simplifying can be done, so now when I multiply, my numerator, 3 times 2 is 6. My denominator, 1 times 5 is 5. This complex fraction in simplest form is going to be equal to the fraction 6/5. Notice that the numerator and the denominator are now integers. Similarly, with example number 2, 25 over 28, or 25/28 over 5/4 is the division problem 25/28. divided by 5/4. And again, instead of dividing by 5/4, we'll multiply by the reciprocal of 5/4, which is 4/5. Okay, I can simplify with 5 and 25. 5 goes into itself once and into 25 5 times. I can also simplify with 4 and 28. 4 goes into itself once and into 28 7 times. Now when I multiply, the numerator 5 times 1 is 5. Denominator 7 times 1 is 7. This complex fraction in simplest form is going to be 5/7. In example 3, we're told that Sergio is training for a triathlon. His target speed is 25 miles per hour. Did he achieve his target speed for the first 7 miles of his ride? Okay, so if we look at the picture here, we can see there's Sergio on his bike and he's gone a distance of 7 miles and he went 7 miles in 15 minutes. We need to see if this is helping him get to his target speed of 25 miles per hour. Okay, so what I'm going to do is going to create some rates here, and I'm going to do it as miles over hours. Okay, because again, that's what his rate is measured in, is miles per hour. And if I look at the picture, I can see that Sergio has gone 7 miles in 15 minutes. Now, I need to convert this into hours. 15 minutes is 1/4 of an hour. So there it is. There's my complex fraction, 7 over 1/4. Sergio's gone 7 miles in 1/4 of an hour, which again is 15 minutes. We want to know, what is Sergio's rate in miles per hour? So I've got to be able to go from 1/4 of an hour to 1 full hour. Well, to go from 1/4 of an hour to an hour, I have to simply multiply by 4. 1/4 times 4 is 1. So I'll do the same thing to my number of miles. 7 times 4, that gives me 28. Okay, so this means that Sergio is biking 28 miles per hour. So he did reach his target speed. Sergio did reach his target speed. He's biking 28 miles per hour, and his target was 25 miles per hour. Okay, with the follow-up question, it says that Sergio increases his target speed to 30 miles per hour. How many more miles does Sergio need to ride in a quarter hour to achieve that target speed? Okay, so we're going to set this up as miles over hours. Okay, and this time we're going to go in reverse. Here, I knew how many miles he went in a quarter hour, and that helped me figure out what his speed was. Well, in this example, I'm going to use this speed, and then I'm going to scale back to figure out how many miles he has to go in a quarter hour, all right, in order to maintain that speed. So Sergio's going 30 miles per 1 hour, and we want to know, how many miles does he have to do every quarter hour? So to go from an hour to a quarter of an hour, we would have to divide by 4. 1 divided by 4 is 1/4. We'll do the same thing here. 30 divided by 4. Okay, and when we do that, 30 divided by 4 is 7 and 1/2. Sergio's going to have to go 7.5 miles every quarter hour to get that target speed of 30 miles per hour. Now, right now, he's going 28 miles per hour, which was 7 miles in a quarter hour. How many more miles does he need to do every quarter hour to achieve that speed? Well, he needs to go 7.5 miles in a quarter hour. Right now, he's going 7 miles in a quarter hour. So if we subtract those, 7.5 minus 7, we get 1/2. Sergio needs to bike an extra half mile each quarter hour. Sergio needs to bike an extra half mile each quarter hour in order to reach his target speed. In example 4, we're told that Bryn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take for her to mow the entire lawn? Okay, so again, we're going to set up some rates here. We're going to set these up this time as square feet per hour. Square feet per hour. Okay, and we're going to look at the rate that Bryn mows. She can do 12,000 square feet in 2/3 of an hour. Okay, so that is our complex fraction. Now, we know that the entire lawn is 36,000 square feet. So I'm going to set this equal to another rate where the numerator is 36,000 square feet. And to scale from 12,000 to 36,000, I would have to multiply by 3. 12,000 times 3 is 36,000. So to figure out how long it would take to mow that entire lawn, I'm going to take my 2/3 of an hour and multiply that by 3 as well. 2/3 times 3, well, those simplify to ones, and you're just left with 2 over 1, which is 2. So it takes Bryn 2 hours to mow the entire lawn. Bryn takes 2 hours to mow the entire lawn. Okay. Now we have a follow-up question underneath. We're told that every other weekend, Bryn's brother Daniel mows the lawn. He can mow 15,000 square feet in 3/4 of an hour. So who mows the lawn in less time? So again, we'll set this up as square feet and hours. And once again, we know that for Daniel mows 15,000 square feet in 3/4 of an hour. The entire lawn, again, is 36,000 square feet. So we're going to have to figure out, how do you scale from 15,000 to 36,000? Well, if we take out our calculator in order to figure that out, all we have to do is 36,000 divided by 15,000, and that gives me a decimal of 2 4/10. So if I do 15,000 times 2 4/10, that's going to get me to 36,000. So that means I'm going to have to take my hours and multiply that by 2 4/10 as well. So I have my 2 4/10 times 3/4, remember, is 75/100. And I can see there that it's going to take 1 8/10 hours, 1 8/10, or 1 4/5 hours. Okay, so Daniel mows the lawn in 1 4/5 hours. Bryn, remember, took 2 hours to mow the lawn. That means, so Daniel is faster. Okay, Daniel is faster than Bryn. Daniel takes 1 4/5 hours, while Bryn took 2 hours to mow the lawn. Now, I could also do this by figuring out their unit rate, how many square feet per hour that they mow. If I come back up here for Bryn, to get the amount that she mows in 1 hour, I just have to take this and divide by 2. 36,000 divided by 2 is 18,000. Okay, well, similarly down here for Daniel, if I wanted to figure out his unit rate, to get to 1 hour, I'm going to have to divide by 1 4/5. So I would do 36,000 divided by 1 4/5. Okay, well, 36,000 divided by 1 4/5, that's the same as dividing by 9/5. Well, that's really going to be the multiplication, 36,000 times 5/9. 9 goes into 36,000 4,000 times. So 4,000 times 5 is going to equal 20,000. Daniel can do 20,000 square feet in an hour, while Bryn can only do 18,000 square feet in an hour. So again, Daniel mows faster than Bryn. In example 5, they say that Omar knows that his friend Chris lives 3/5 of a mile away. How far is the school from Omar's house? And underneath the question, we have a map here. And the distances on the map, notice, are different, obviously, than the distances in real life. A map is a scaled down version, in this case, of Chris's village. And so we can see that the distance between Omar's house and Chris's house on the map is 3/4 of an inch. In real life, that's 3/5 of a mile. Omar knows that Chris lives 3/5 of a mile away. So in real life, this is 3/5 of a mile. Okay, the question we want to know is how far is the school from Omar's house? On the map, we can see that Omar lives 2 inches away from the school, but we don't know what that is in real life. Okay, so what we're going to have to do is use this information that they gave us about Chris and see if we can determine how many miles every inch on the map is going to be so that we could figure out this distance in real life. 2 inches is how many miles in real life. So let's go ahead and set this up. We can do miles over inches for our rates. And again, they tell us that Chris's house in real life is 3/5 of a mile away. On the map, that's a distance of 3/4 of an inch. What I want to do is figure out the unit rate of miles to inches. In this case, how many miles is every inch going to represent on our map? So to go from 3/4 to 1 mile, or inch rather, we're going to have to divide by 3/4, which means I'm going to do the same thing up here. 3/5 divided by 3/4. And if I do that math, 3/5 divided by 3/4 is the same as doing 3/5 times 4/3. And these three simplify the ones, which is going to make 4/5. So this is going to equal 4/5. So on the map, every inch in the real life is going to be 4/5 of a mile. Now, on the map, from Omar's house to his school, it's a distance of 2 inches. We have to scale from 1 inch to 2 inches, and we can do that easily by multiplying by 2. If we do the same thing in the numerator, 4/5 times 2, well, that's going to be 8/5. 4/5 times 2 is 8/5. And so I now know that this distance on the map is 8/5 miles. 8/5, though, is the same as 1 3/5. All right, so this is 1 3/5 miles. Omar lives 1 3/5 miles from school. Okay, so again, the first thing that we had to do was figure out what the scale was in terms of miles and inches for this map. All right, every inch on the map is 4/5 of a mile in real life. Then we just go from 1 inch to 2 inches by doubling it. 4/5 times 2 is 8/5. So that means that Omar lives 1 3/5 miles from school.